Okay, so this is Chapter 16D, solving problems using the normal distribution. Question 7. The height of a certain population of adult males is normally distributed with a mean 176 and standard deviation 7. So first of all, I'm going to define a variable that is normally distributed with a mean of 176 and standard deviation of 7, and I'm going to find the probability that the height of a randomly selected male will exceed 190. So it's probability that x is greater than 190. And I'm just going to use the CAS for that. So go into statistics. We're doing a calculation with a distribution. This is normally distributed cumulatively. The lower bound there is 190, the upper bound is infinite. The standard deviation is 7 and the mean is 176. Okay, so that gives me a probability of 0.227, 0.228. Alright, B, if two males. So now we have two people, same probability, so we can just get this through multiplication, assuming it's independent. So we would have the probability of the first male and the times the probability of the second male, so 0.0005. And then C, suppose 10 males are selected at random, find the probability that at least 2 will have heights that exceed 190. I'm going to define an event A, which is that a male is taller than 190 centimeters. So now you'll note this is either, the event is either that the male is taller than 190 or not taller than 190. So what I've done there is I've turned my normal distribution into a binomial distribution by defining an event where they're either taller or not taller. Okay, so there's two possible outcomes, only two possible outcomes. So that makes it binomial. A is binomial, and the probability is 0.228, and I've got 10 trials, and I'm after the probability that A is greater than 2. And so I'm just going to do that on the calculator. I am doing a binomial CD. The lower is 2 and the upper is 10. Out of 10 trials with probability of 0.228. And so that gives me the probability there of being 0.206. Okay, so now we're going to look at 16D question 8. Machine is packaging bags of mints with a mean weight 300. And they are underweight if they weigh less than 295 grams. It is observed that on average 5% of bags are rejected as being underweight. Alright, so I'm going to draw a bell curve. We have a mean of 300, and 295, and the area under the curve left of 295 is 5%. Okay. And we need to find the standard deviation of the distribution. So we're going to use a standard normal distribution to help us calculate this. I'm going to go ahead and draw that distribution as well. So it has a mean of 0, and it has some point here, some z-score here that also has probability of 0.5. That's area under the curve there of 0.5. And so what we want to know is the value of that z-score. So we can just get that off the CAS. So now my lower bound is negative infinity. No, we're not doing that. We're going to do a inverse distribution, because we know the probability and we're trying to find the values. So we have a left center and we have probability of 0.05, and that's standard, so we can leave those as they are. And that tells us our z-score there is negative 1.644. And so just draw that and make sure that it looks like what we want it to look like. So that is the 0.5 is the blue shaded area there. So that checks out. So we have negative 1.644. So that's that z value there. Now what that means is the distance in standard deviations, that distance is 1.644 standard deviations, which means that this distance here is also 1.644 standard deviations. Okay, so because these probabilities are the same, that means they're the same distance from the mean in terms of if our distance is standard deviation. So if we take that 5, the distance from here to here is 5, so if we take that 5 and we divide it by 1.644, that will tell us that our standard deviation is standard deviation is 3.039. Alright, this is standard deviation. Now, more formal way to do this using the rule, we would say that z equals x minus mu over sigma. Okay, that's the rule. So our z-score was negative 1.645. Our x value is 295. The mean is 300. And sigma is what we're trying to find. And so rearranging that, we find that standard deviation is there. Alright, now, so question B. So basically the same question, but we're being asked to find the mean instead of the standard deviation, but the process is exactly the same. Okay, so this is essentially the same question as before, except we're finding a mean instead of a standard deviation. So on our new distribution, we have underweight at 340, and that is now 2%. And so on our standard normal curve, we want to find the z-score that has that area as 2%. Okay, so it's 0.02 and left tail, and so it's our Z score, and just graph that, make sure that we're on the right track. Yep, so that's the Z score there. So now we have same formula as before, so Z equals X minus mean divided by standard deviation. So Z score, the X value is now 340, the mean we need to solve for, and standard deviation is 5, and if you just plug all that into the CAS, we get a mean, you got to times that by -1, so we get a mean of 350.2. Alright, and so that's our mean. So we can stick that in our graph,